Hello, Math Masterminds. We're going to continue our geometry unit working with volume, but we're going to add cones. We know that volume is the amount of space a 3D object occupies. We've talked about cylinders. Now we're going to add cones. Notice a cone still has a circular base, so my big B is going to still be the area of a circle, which is pi r squared. But notice my volume of a cone formula is 1/3 big B times height, because we're going to see that a cone is 1/3 the size of a cylinder when the radius and height are congruent. First example, Mr. Rodriguez displayed the following solids and demonstrated to the class that the areas of the bases and heights are the same for both solids. He posed the following question. What do you predict is the relationship between the volume of the cylinder and the volume of the cone? Alden and Lim were asked to share their conjectures with the class. Alden states, I think the volume of the cone is 1/3 the volume of the cylinder. Lim says, I think the volume of the cone is half the volume of the cylinder. Stop the video. View the volume of a cylinder versus cone video in today's folder and come back. Welcome back. After viewing the volume of a cylinder versus cone, you should have realized that Alden is correct, that a cone is 1/3 the size of a cylinder. Example 2. Which of the following does not describe the relationship between the volumes of figure A and figure B? F. The volume of figure B is 1/3 the volume of figure A. G. The volume of figure B can be found by tripling the volume of figure A. H. The volume of figure A can be found by dividing the volume of figure B by 3. J. The volume of figure A is 1/3 the volume of figure B. Which one does not describe the relationship? Well, I hope you said F. The volume of figure B is 1/3 the volume of figure A. No, the cylinder is larger than the cone. Next example, a cone-shaped party hat has a radius of 3 inches and a height of 6.5 inches. What is the cubic units of space in the party hat? First, let's identify what information is given. It says cone-shaped. It also asks about cubic units. Nowhere in this question is it saying volume, but I have to use the information that's given in order to determine that cubic units refers to volume. So I'm going to, again, use my formula for volume of a cone. Big B is the area of a circle, so I'm going to substitute pi r squared in place of big B. My formula calls for radius and height, so I'm going to look back into the problem and see, am I given the radius? Yes. Am I given the height? Yes. So I'm going to substitute these values for the variables. And now I'm ready to calculate using the pi key, not 3.14. And I get 61 cubic centimeters of space in the party hat. Next example, Sammy has a cone-shaped planter hanging on her back porch. If the planter has a radius of 6.5 inches and a height of 12 2/10 inches, what is the total amount of soil the planter will hold to the nearest tenth? Once again, I'm going to look at what information is given. It says cone-shaped. And here it says the planter will hold. That means volume once again, the amount of space. So I'm going to use volume for a cone. Big B is still a circle, so I'm going to substitute pi r squared in place of big B. My formula asks for radius and height. I'm going to look to see, do I have radius? Yes. Do I have height? Yes. So I'm going to substitute those values in place of my variables. And now I'm going to multiply using the pi key, not 3 and 1400ths. And I get the volume is 590 and 8/10 centimeters cubed